Okay, this video is going to review the acceleration worksheet. You have the equation up at the top of the paper, and then you just have to plug in the numbers with the equation. Okay, so the equation's up here at the top. Final velocity minus initial velocity divided by time. So number one is already done here. So it says the roller coaster car rapidly picks up speed as it rolls down a slope. It starts, so you gotta look for keywords for this, like starts. That would mean the initial velocity. That's how it starts. So it starts down the slope. Its speed is 4. So as you see here in the equation, I put the 4 here. That's where it starts. Then 3 seconds later, so here we get the time. That's why this is shown here as the time. 3 seconds later, at the bottom of the slope, its speed is 22. So after the time of 3 seconds, that's its speed or velocity. So you have the initial velocity of 22. The initial velocity of 4, the final velocity of 22, and then you would just subtract those numbers and then divide. So you do 22 minus 4, that's going to be 18. Put the 3 down here on the bottom, and then 18 divided by 3 is 6. Okay, similar process on number 2. So a cyclist accelerates from 0, so from, that would be the initial, from 0 to 8. So it goes from that to this. So 8 is the final. And once again, also that takes 3 seconds. So it wants to know about the acceleration. So you would just do 8 minus 0 over 3. And you can divide that using the calculator. And it wants to know, is this acceleration higher than a car which accelerates from 0 to 30? So from 0 to 30 in 8 seconds. So you would then subtract and divide here. So you're going to end up comparing these two numbers to see which one accelerates faster. So you just got to divide here, and you can round to 2 decimal places. Number 3, so the car advertisement states that a certain car can accelerate from rest. So from rest. If something is resting, it's not moving, the velocity would be 0. So from rest to 70, so that's the final velocity, and it takes 7 seconds. So once again, just subtract, you get 70 over 7, and you divide, and don't forget to label meters per second squared or meters per second per second. A similar process on number 4. And remember, it gives you the initial velocity for this. So you can plug in the initial velocity. It tells you the rate. And it tells you how long that happens for 3 seconds. This one's a little bit different though. It tells you the initial velocity and it tells you it speeds up at a rate of 50 meters per second for 30 seconds. So this one, you're not going to use the exact same formula because you're just trying to find the final velocity, not the acceleration. So if something speeds up 50 meters per second every second, that means after 1 second, it'd be going 50. After 2 seconds, it'd be going 100. And then after 3 seconds, it'd be going 150. So it's speeding up 50 meters per second every second. And the initial velocity was 10. So you just need to add the initial velocity to the acceleration. So this one you might get a negative number because it says the driver is going to be slowing down from this. So this would be the initial to this. This would be the final. So for this one, you will get a negative number. Set up the equation the same way. Just notice that you will get a negative number. Number 7, similar, right? From 85 to 45. So similar to number 6, set up the equation the same way, right? So you're going to have a negative number. So from, that's the initial, to 45. And that takes 4.5 seconds. So when you subtract, you'll get a negative number. So subtract 85 and 45, find the difference, and then you'll divide by 4.5. So you'll get a negative number here and divide it by 4.5. So your answer will be a negative acceleration. So number 8, car traveling at a speed of 30 meters per second comes to a complete stop. So that's going to be the final velocity of 0. And it says how much time will it take for the car to stop if it decelerates at 4 meters per second every second. So this one's also slightly different. It does give you the final velocity. It gives you the initial velocity, but it wants to know the time. It gives you the rate of -4. So you're basically kind of working backwards and solving for t. So you'd multiply by t over here. So -4.0 times what to get this -30 here? So remember, you would multiply by t on both sides. These would cancel. And then you're going to solve for t on the right here. So you'd end up with an equation like this because you will get -30 here because 0 minus 30. So you'd get -30. These t's eliminate equals -4.0 t. And you should know how to do this from math class, right? Just divide by -4.0 on both sides. And then that will give you the time. So you'll just continue. Number 9, similar question. So once again, you'll need to use some algebra skills here, right? You need to get the final speed. So it gives you other information, but it does not give you the final speed. Okay? So it says it starts, right? It's going to take 5 seconds, has an acceleration of 4, and its beginning speed of 2. It wants to know the final speed. So this one's like ones we've already done, right? Increasing from this to this in 5 seconds. Let's just set up the equation, plug the numbers in. Similar here, this one's going to be negative acceleration or deceleration. This one's going to be one like we did before. You might need to multiply first because it's giving you its acceleration rate and how much time and how fast it was going. So this one you can do just by having the initial velocity here, 25 meters per second, and it's going to be accelerating 7 every second for 6 seconds. So for this one, you can multiply, basic multiplication, right? 7 meters per second for 6 seconds, that'd be 42. So you would just need to add those rates together to get the final speed. Once again, for this one, also you'll need final speed. This one, you'll need the acceleration. And another one here also. The acceleration rate, it wants to know how much time it will take.